Hi, I'd like to take a few minutes to explain how we've been working to use the semantic web to solve a surprisingly big problem people have with spreadsheets, and a surprisingly big opportunity, actually. So let's get straight to it. Let's look at an ordinary spreadsheet here. It's got the zip code map of the United States. There's about 41,000 rows. A lot of non-business people don't realize, in fact, that people use spreadsheets not just for calculations, but to just dump data. It's a great big recycle bin. So the guts, the core of the problem that non-business people may not fully realize is that if you've got two spreadsheets here that are quite separate, but really they're intuitively share a common column. What normal non-technical people want to do is for each employee in this spreadsheet connect it up to all the address data over here in another spreadsheet. At the moment they have to cut and paste between them. It's a real pest. What we do is we allow them to put the spreadsheets in a subdirectory. We then generate a full semantic model. Here it is. You can see one semantic concept. You can see another one. They're the same spreadsheets. You can browse the spreadsheets individually and see the results coming back. Or by highlighting the columns, you're effectively doing a query. You're saying, tell me all about the people we know, and go off and get their names and addresses and bring it all back. And this is great stuff for ordinary business people that want to do simple joins. Now if we move to a more industrial strength thing, here we've got a lot of gene chip, Affymetrix gene chip life science data, and you can see there's nearly 1 million rows of results, 900,000 or something like that. So you typically, a scientist has got a large amount of data from a gene trial. They've got a database that tells them about the individual genes and how they all work, and another one about whether the probe sets are good or not. The big business point is you've got 1 million rows, you've got 18,000, you've got 30,000. It's a challenge, and currently people have to go to those spreadsheets and literally here again we've generated the semantic concepts from the spreadsheets, and whilst they could just browse through any one particular spreadsheet, it doesn't get you very far looking at 1 million rows. What they're able to do now is, and this is all taken care of by this Sparkle stuff, which happens transparently to them. We're able to go in and do a query such as find all of the way the fold change, the way in which these genes are behaving differently in this species according to this particular test, so we can go off and do that. And bear in mind, we're getting the machine to compare 1 million rows with 18,000 by 30,000, so we're solving a big productivity problem for the science. Now I should point out that our customers don't care that under the hood we've generated an ontology and that the command that's been generated is in this stuff called Sparkle. That doesn't really matter to them. They wouldn't expect to program in this stuff. It's not relevant. All they care about is getting the results, and that's essentially what we're delivering, a productivity benefit for them to get straight to the answers they want very, very quick. However, so far we've been looking at using the semantic web to solve a productivity problem of lots of columns, lots of rows. However, people use spreadsheets enormously, and here we're going to show again more spreadsheets. This is one of our drug company clients. They've got these Affymetrix results, they've got other information. These are all in spreadsheets. That's what scientists use. These images are defined in a spreadsheet, but the images are 2 to 10 gigabytes each in size, so people are able to do quite sophisticated queries and come back with the results of the data, which we have a special browser that allows us to review images that are results of semantic queries. So here the scientists can find one image out of many thousands, many hundreds of thousands, and navigate through them according to the metadata that is describing the images. So you can, the point here is you can do very sophisticated little mini applications put together by scientists where they're using the semantic web to do things they just couldn't do before. So now we're going to look at one more very common problem which happens all the time in project management. People use Microsoft Project throughout the world. There are millions of users of it, and what we find is that people have these colossal collections of concurrent projects going on at any one time, especially these days. And here we've got 15 odd different projects, but each one, and they're glorified spreadsheets really, has got hundreds of columns of data. And that really doesn't help business people very much. What they want to do is ask a simple question, which we allow them to do. In other words, from the hundreds of columns, there really are only about 3 or 4 semantic concepts. There are resources, also known as human beings. There are how they're assigned, and there are tasks that they work on. And we automatically generate the ontology that underlies all of this, and so ontology here, all taken care of. And more importantly, the business user can then say, right, I'm interested in finding out, not just for one project, which is quite easy, but for 15 concurrent projects, which human beings are over-allocated across the set of all of these projects, so I can discover my risk. And we just click on the relevant concepts and the attributes and press the button, and we can get the answers. So how this is done, well, people don't really care. The sparkles generated, that's not really too important to them. What they want to know is the results. Now let's move on to Bran Neiman, who's single-handedly pioneered the science of having colossal numbers of spreadsheets containing very useful data, but which turn out to be really quite hard. It's quite a challenge knowing how to manage them, how to get sensible answers out of them. Let me just explain. So in Bran's world, he has, I'll just get rid of this, he's got something like, well, he's got exactly 327 spreadsheets, a report on the environment, including air, water, and so on. I'm just showing air and water, which is about 100 and something here. So they've all got tremendously interesting information in them, but that's a nightmare. We've looked at lots of columns, lots of rows. Now we're looking at lots of spreadsheets, and what we want to do is find out how we can intelligently query these. So let's just have a think for a moment. So we've got 327 spreadsheets, and what we're actually interested in doing is finding the answers to the interrelationships between lots of data. So what we've done is, this is incomplete work. We need to find a useful intern that may be able to help us, is if you imagine the 327 spreadsheets divided up into piles, clumps of, let's say, 15, where spreadsheets are stacked on top of each other like paper, like letter-sized paper. We've done this. It's called a union. It doesn't really matter. It's like pancaking the spreadsheets together. So we've allowed people to find similarly shaped spreadsheets. Brand has a great deal where he's measuring something. He's measuring something by region, and we're able to clump these things on top of each other. And now the query we're doing is, as it were, drilling down through a great big stack of spreadsheets. Here we're doing the same kind of thing. These are clumped together, again by region, but by average per year. And over here we're doing it, the measurement is by year rather than by region. So now we've got a situation where we can ask questions that will transcend across all of these three. And as I say, I would estimate about 10 to 15, and you'd have the entire EPA model all queryable by any sensible human being. So the summary we've tried to show here is that you can have large numbers of spreadsheets, you can have large numbers of rows, you can build complex applications, and the semantic web allows you to do this really for the first time, because it solved the problem of letting business users join together data without having to write code. And this is something programmers have not really understood. It's really important for business people to be able to get the answer to this very quickly, and it springboards them to be able to move on and do sophisticated applications such as the one that we looked at earlier with the imaging. So I hope this helps. Be delighted to chat with you, and thank you very much.